Everyone, Rohit Dalal, lecturer, Electronics and Communication Engineering Department, Jain Polytechnic, Belagavi. Today I am going to discuss unit number 3, registers and counters. In this lecture, I am going to discuss regarding counters, okay, and also modulus, classification and its applications. Okay, so what is counter? Counter is an electronic circuit used to count the number of clock pulses arriving at the clock input. Okay, the counters are constructed using the series of flip-flops, okay, and also any flip-flop can be suitably connected to a form counter. You widely used R, D and JK flip-flops, okay, and also you can define counter is a digital sequential logic device that will go through a certain predefined states based on the application of the input pulses. They are utilized in almost all computers and digital electronic systems. Okay, so this is a counter. Okay, so counter is going to count the numbers. Okay, it is an electronic circuit used to count the number of clock pulses arriving at the clock input. Modulus of counter: the number of different states of a counter can produce is called the modulo or modulus of the counter. The modulus or mod number of a counter is total number of unique states it passes through in one complete counting cycle with the mod n counter being described also as a divide by n counter. It is also called as the natural counter. In general, the mod n counter can be increased by adding the more flip-flops to the counter, that is mod number equal to 2n. N is the number of the flip-flops. Okay, so there will be two types of the counters. Okay, first one is synchronous and second one is the asynchronous. Okay, so synchronous counters are constructed with the one common clock signal as the input to the all the flip-flops simultaneously. The clock does not have ripple through the counter stages. Okay, and also the synchronous counters are also known as the parallel counters due to parallel manner that clock is fed to the counter stages. Okay, so you can observe the 4-bit synchronous counter waveform diagram. Okay, circuit diagram. Okay, there is a LSB and MSB will be there. Okay, JK flip-flop I am using here. Clock is common clock. Okay, so J equal to 1, K equal to 1 I am providing. Okay, so there is plus 5 volt. Okay, so you can observe this synchronous counter. So next, asynchronous counter. Asynchronous counters are also referred as the ripple counters. The incoming clock waveform is connected to the first flip-flop of the counter, which generates the LSB of the number in an output sequence or a count sequence. The output of the first flip-flop is connected as the clock input to the next flip-flop. Each flip-flop of an asynchronous counter obtains its clock signal from the output of the prior flip-flop, which results in the clock signal rippling through all the flip-flops of the counter. 4-bit asynchronous counter is shown in the figure. You can see the circuit diagram. Okay, so clock will be there. Okay, so here what your incoming clock is a waveform. Okay, that is connected to the first flip-flop only. Okay, means that next flip-flop output is connected to the clock. Okay, so that it is separated. Okay, we generates the LSB of the numbers in the count sequences only. Okay, the output of the first flip-flop is connected to the clock input of the next flip-flop. Okay, in asynchronous counter you can observe the asynchronous counter waveform circuit diagram here. Okay, so applications of the counters are frequency counters. Okay, digital clocks, analog to digital converters with some changes in their design. Counters can be used in the frequency divider circuits. In time measurements, we can design the digital triangular wave generators by using the counters. Okay, and there are different comparison between the synchronous and asynchronous counters. The propagation delay is very low. Propagation delay is higher than that of synchronous counters. Its operational frequency is very high. The maximum frequency of the operation is very low. These are faster than the ripple counters. These are slow in operations. larger number of the logic gates are required to design, less number of logic gates are required. It is a high cost, it is a low cost. Synchronous circuits are easy to design, complex to design. Standard logic packages are available, okay, and for synchronous counter standard packages are not available. Okay, so in this session we have discussed what is the counter, okay, and also modulus and classification and its applications of the counters. Thank you.